This is our sixth class, and we are yet to finish this chapter, and we have two more classes left. So, to begin with, in today's class, we will be discussing a very important topic, a topic which we will be requiring in almost every time whenever we use integration. This is a very important tool of integration called integration by parts. So, let us see how to deal with such problems. First, to begin with, let us know what is integration by parts. Now let us consider two functions of x. One is u, the other one is v, and u being a differentiable function and v being an integrable function. Now, what is the meaning of u being differentiable? U being differentiable means its derivative exists, and v being integrable means its integral exists. Fine. So if that happens, if that is the pretext of what we are going to do, then let us see what happens. So let us try to find out the derivative, that is ddx of u into integral of v dx. So what we are trying to do, we have got two functions, u and integral of v, and we are trying to find out its derivative. So this is one complete function. So if we try finding its derivative, see what happens. This is what happens. Derivative of uv, that is in the chain rule, or not chain rule, that is the multiplication rule of derivatives. So that is du dx into integration of v dx plus u into ddx of integration of v dx. That's exactly what happens. Now in the next step, obviously derivative of integration, it nullifies each other, because derivative and integration, they are just the opposite operation. So derivative of integration will leave us with only v. That is, in this case it will become this, only v. So then what do we do in the next step? The next step will be to take this derivative on the other side. So now we know that if, let me just give you an idea. So if I am having derivative of say u, that is equals to v, then definitely if I take this derivative on the other side, then u is equals to integration of v dx. So derivative going on the other side becomes integration. So therefore if I want to take this derivative on the other side, then it will turn into an integration. So let me do that. So therefore when I take this on the other side, this derivative on the other side, then this becomes an integration. See, this is how it happens. Integration, but integration over x. So therefore after this, if we just do some side transposing means sending this on this side, then what happens? We have integration of uv dx, that is equals to u into v dx minus integration of du dx into integration of v dx whole dx. So therefore this is exactly what you get. And this formula is called the formula for solving integration by parts. So this is exactly the formula which we need to remember, which we will be using for solving our problem. Now obviously the function which is differentiable, that is also called the first function. The function which is integrable is also called the second function. Now there is a particular order of choosing the first and second function. Now the order is basically I let. Now this eyelet order can be also, in some different books you can see that L and I are sometimes exchanged. It is also written as LIATE. Now what does this stand for? I stands for inverse trigonometric functions, tan inverse, sine inverse, all those things. L stands for logarithmic functions, all different kinds of log. So it can be log, log base, a, whatever. A stands for algebraic functions, so x, x square, x plus 1 whole cube, anything. T stands for trigonometric functions, so it can be sine x, cos 2x, anything. And E stands for exponential functions, so e to the power x, e to the power 2x plus 3, whatever. So these are all the different kinds of functions that we have. Now obviously inverse trigonometry and logarithmic, they can be switched in their places, so you can take any one of them first, or means either of them you can take at the beginning, no problem. So now this order of function is such that as the order goes down, the functions become more and more integrable, and as the order goes up, the function becomes more and more differentiable. So therefore the idea is to choose the differentiable function, always take the one which is up the order, and to choose the integrable function, choose the one which is below the order. So, and in any case you will come across problems where you have problems where there is almost both the functions are of similar order. Then you can always choose any one of them as the differentiable, the other one as the integrable, no problem. So now let us move to the problems and let us see how to deal with this. Now the first one, integration of x into sin x dx. Now see here, x is an algebraic function, sin x is a trigonometric function, so algebraic function comes before trigonometric function in the order. So therefore this can be chosen as the first function and this can be chosen as the second function. So it is not necessary that you always mark them, but it is good to mark so that you can the one who is checking your paper, he or she will be knowing that you understand what is happening here. Now in that case, once we break it, this is what happens. Integration of x sin x dx, that is x into integration sin x dx minus integration of d dx of x into integration sin x dx whole dx. Now integration of sin x is minus cos x, so that gives you minus x cos x, plus d dx of x is 1 and integration of sin x is minus cos x, so that makes it plus outside, and then we have integration of cos x dx, that becomes sin x plus c. So always remember, whenever you are doing integration by parts, the first job is to put the constant of integration after all the integral signs are removed. Do not put in plus c as long as there is an integral sign. So the last integral sign being removed, you have already calculated all the integrals, you have found the answers, then only you can go on putting the integration constant. Fine. Next, evaluate x square e to the power x dx. Now x square e to the power x dx, to begin with, x square is algebraic, e to the power x is exponential, so we start off with e to the power x as the second function. So if we do so, then this is what happens. X square comes out, integration e to the power x dx, derivative of x square, that is 2x, into integration of e to the power x, that is e to the power x only. So I have skipped that one step. Now though you are free to do so, because Here there would have been one extra step I haven't written, so it would have been something like this: ddx of x square into integration of e to the power x dx whole dx. I haven't written this step, I have directly written this one. So obviously if you understand this step and you can calculate it just mentally, then you can definitely put it, you need not go on writing it. Next, so again you see this one, x e to the power x will become another by parts, so we have to break it once again. So x is coming out, e to the power x dx, and ddx of x is 1, and integration of e to the power x is again e to the power x, so this is what remains. And then if you just calculate all the integrals and put the values, this is your final answer, right? Go through the problems, I hope you understand. Number 3, integration e to the power x sin x dx. Now see here, this is exactly the problem which I was talking about. Now in the order, trigonometric function and exponential function, they both come at the lower part of the order, so you can consider any of them as the differentiable and any of them as the integrable function, because basically trigonometric function and exponential function, they are differentiable everywhere, they are integrable everywhere, so generally it doesn't make any difference. So considering any one of them as the first function and the second function is fine. So in my case, what I have done, I have chosen e to the power x as the first function and sin x as the second function. So nobody told you to do so, but you can do it. And also here I have done another thing, I have considered the whole integral as I. Why I have considered it as I, we will see it just in a bit. So e to the power x as the first function comes out, and integration of sin x dx, then derivative of e to the power x is e to the power x, integration of sin x is minus cos x, so that remains inside the integral. Then we have I have done a small mistake here. The mistake being, here should have been a minus sign, I forgot to give that minus sign, please ensure. And then here what we have, e to the power x into integration cos x and minus integration e to the power x sin x. So this is another by parts, which when we break we get this. Next, e to the power x into cos x dx, that cos x integration becomes sin x, it comes out. This problem I have made so many printing mistake. This is cos x, whatever. Now minus I, why minus I? This whole thing is exactly the thing I started with, so therefore I can write here as I. So now if I take this I on the other side, it becomes 2i. So in the next step I have written cos x, I forgot to write here cos x, and this plus should be minus actually. This plus should be minus. I forgot to write that. Anyway, now take this 2 on the other side, so therefore your final answer is e to the power x, that is equals to, I equals to, that is the integration, that is equals to e to the power x by 2 sin x minus cos x. So there is minus, here is also a minus, here this should be cos x, and there is a minus here also there is a minus. So please ensure there are certain signs mistake which I have done, that is a completely typing mistake. All right, I hope you have understood the problem. Now you could have done it by taking sin x as the first function as well. It would have given you the same answer. Okay, next problem, number 4. Integration tan inverse 3x minus x cube by 1 minus 3x square dx. Now obviously, before we can solve this problem, we have to do certain things. The certain things being taking substitution. Now let us take x as tan theta, then dx becomes sec square theta d theta. So inside quantity of tan inverse becomes something like this, which we know as the tan 3 theta formula. So tan inverse tan 3 theta is actually 3 theta. So this is exactly what our integration is, 3 into integration theta sec square theta d theta. Now you can see theta is algebraic because it is just the single variable, and sec square theta is trigonometric. So therefore theta can be considered as the first function, sec square theta can be considered as the second function. So if we do the integration, this is what happens: 3 theta into sec square theta d theta minus 3 tan theta. Obviously derivative of theta is 1, integration of sec square theta is tan theta, so you are left with 3 into tan theta d theta. So therefore in the next step you get integration of sec square theta as tan theta, so 3 theta tan theta, and integration of tan theta is log of sec theta, so 3 into log of mod of sec theta plus c. Now it's time, let us put back the values. So if tan theta is x, theta is tan inverse x, and log of sec theta. Now what is log of sec theta? Let me just solve it for you. Now sec theta is basically root over of 1 plus tan square theta, that is root over of 1 plus x square, or it can be written as 1 plus x square whole to the power half. Now whole to the power half inside log comes out, so it becomes 3 by 2 log of 1 plus x square. So therefore this is your final answer. Right? That's it. Next, number 5, or before number 5, we have a different kind of integration, and let us first understand how that different kind of integration works, and then we will go into the next problem. So let us consider a problem where we have this kind of a situation where we have e to the power x into fx plus f dash x, means e to the power x is multiplied with the sum of a function and its derivative. If this is the situation we are having, how to deal with this? To understand what happens, let us start with an integration, and let us take the integration, this integration of e to the power x fx dx. So now integration of e to the power x fx dx can be written as taking fx as the first function, e to the power x as the second function. We have this fx into integration e to the power x dx minus integration e to the power x into f dash x dx, right? Fx is the first function, so derivative of fx is f dash x, and e to the power x integrated remains e to the power x. So in the next step we have this e to the power x fx minus integration e to the power x f dash x dx. Take this on the other side. If I take this integral on the other side, then what do we get? We get this. This goes on the other side with e to the power x fx, then e to the power x fx plus f dash x dx, that is equals to e to the power x into fx plus c. So we need not know how the formula is coming, but we only need to remember the formula, just this part. And we will be applying this in our problem. So this is an example from the previous the thing that we just saw. So this is what you are given: integration x e to the power x by 1 plus x whole square dx. So before we can integrate, we need to get it into the form e to the power x into fx plus f dash x. So let us see how to do that. So here what I have done, I have added and subtracted and 1, obviously intentionally. After doing so, after breaking it out, I have 1 by 1 plus x and minus 1 by 1 plus x square. Now it is very easy to see that if I take fx as 1 by 1 plus x, then f dash x becomes minus 1 by 1 plus x squared. So basically what I have fx plus f dash x in that form. So therefore I need not prove the formula, I can directly write, therefore the integral is going to become e to the power x by 1 plus x plus c. So to write this answer directly, I must show this step. This step is important to show which one is fx and which one is f dash x. And once I can show this, then definitely I can write my final answer like this. So that's how we do it. Fine. So that's it. That is our class today. Hope you have understood. We have 2 more classes left and we will definitely finish it on time. Thank you.